Welcome, everyone. Today, we are going to shatter a massive myth, the idea that you need a computer science degree to write code. Whether you want to automate a boring task, build a simple web page, or conquer complex spreadsheets, Claude is your new expert programming mentor. Let's get started. Let's start with a foundational truth: you already think like a programmer. If I had $1 for every time someone told me I can't code, I could buy a small island. The biggest myth is that coding requires you to be a math genius or think in binary. In reality, an algorithm is just a step-by-step recipe. Think about making a cup of coffee or getting dressed. You are executing an algorithm. Programming is merely taking those logical steps and translating them into a specific dialect that a computer understands. Here is where Claude changes everything. You no longer have to spend months memorizing semicolons and brackets. You provide the clear, step-by-step logic in plain English, and Claude acts as your fluent translator, instantly generating the exact syntax needed to instruct the machine. Your job shifts from being a typist to being a director. Take a look at this flowchart, which illustrates your new workflow. At the top, we have your human logic. This is your everyday, plain English understanding of a problem, like saying, I want to add these two columns if the third column says yes. Instead of hitting a wall because you don't know the exact code, your logic flows directly into Claude. Claude acts as the translation engine in the center. Depending on your needs, it branches out to generate a Python script, an HTML layout, or a complex Excel formula. Finally, all these paths converge at the bottom into an automated output. You have successfully controlled the computer without having to memorize the underlying machine syntax. To successfully code as a non-coder, you cannot just throw a vague request at Claude and expect a perfect, maintainable application. We use a 4-phase framework for AI-assisted programming. Phase 1 is concept understanding. Before generating code, ask Claude to explain the programming concepts using simple analogies. Phase 2 is guided implementation. Work with Claude to plan the structure in plain English, then have it write the logic step by step. Phase 3 is review and improvement, where you ask Claude to explain what each line does. Phase 4 is independent practice, where you tweak the code to build confidence. This framework is crucial because if Claude just hands you a finished script, you won't know how to run it or fix it if your environment changes. By collaborating systematically, you ensure that you remain in the driver's seat, fully understanding the logic being deployed. This state diagram maps out the exact progression you should follow for every coding task. You start in Phase 1, understand. Here, you ask Claude to clarify what tools or languages are best for your goal. Once you understand the basics, you transition to Phase 2, plan. You outline the logic, the recipe we discussed earlier. Moving to Phase 3, implement. Claude generates the actual code based on your agreed-upon plan. Finally, you transition into Phase 4, review. You read the code together with Claude, ask for explanations of confusing lines, and debug any issues. This linear, state-driven approach prevents you from becoming overwhelmed by a sudden wall of complex text. Let's dive into our first programming language, Python. In the programming world, languages have personalities. Python is what we call the friendly neighbor. It is explicitly designed to be readable, making it the perfect choice for beginners automating daily tasks or crunching data. In Python, you use simple building blocks. You have variables, which are just labeled storage boxes for information, like name equals Claude. You use functions, which are reusable mini recipes, and conditions, which are decision gates like, if this, then do that. When writing Python with Claude, your best prompt is something like, help me write a Python script for this task, and please add heavy comments explaining what each line does. Because Python reads almost like an English sentence, you will find yourself quickly identifying patterns and understanding how the computer is processing your data from top to bottom. Here we see the fundamental flow of a basic Python script. It usually begins on the left by defining variables, setting up the data we want to work with. The script then hits a decision diamond. Is a specific condition met? For example, is the password longer than 8 characters? If yes, the code flows along the top path, running a specific function task and outputting a success result. If no, it takes the bottom path to show an error message. This is control flow in a nutshell. When you ask Claude to write Python, it is simply structuring this exact logical pathway using code. Moving from automation to visual creation, we have HTML and CSS. I like to call this combination the web wizard. If Python is the engine of a car, HTML is the frame, and CSS is the paint job. HTML uses simple tags to structure a page, telling the browser, this is a header, this is an image, this is a button. CSS provides the rules that make it look beautiful. You might think building a website requires complex software, but with Claude, it's remarkably easy. You simply ask Claude to create a single-file HTML page tailored to your needs, say, a landing page for your new consulting business. Claude will generate the markup and the styles together. You just copy the text, save it on your computer as index.html, and double-click it. It will instantly open in Chrome or Safari as a fully functional, styled web page. It is the fastest way to turn an idea into a tangible, visual product. Let's examine how a web page is constructed. On the left side, we have the HTML skeleton. This defines the core structure using elements like header tags, paragraph tags, and button tags. On the right side, we have the CSS paint job. Notice the dotted lines connecting the two. CSS applies specific rules, injecting styles into the header, colors into the paragraphs, and padding into the buttons. Claude understands this architecture perfectly. When you prompt Claude for a web page, it simultaneously constructs the rigid skeleton and applies the beautiful paint job, handing you a complete, ready-to-view file. For our third tool, we look at the software you probably use every single day, Excel. I call this the data whisperer. Spreadsheets are incredibly powerful, but getting beyond a basic sum function often requires writing complex, nested formulas that are highly prone to syntax errors. Instead of spending hours Googling how to write an index match or a nested if statement, you can use Claude. The trick here is how you describe your data. You must be explicit. Tell Claude, column A contains dates, column B contains revenue. I need a formula in column C that returns the revenue only if the date falls in the first quarter of the year. Claude won't just give you the formula, it will explain exactly how it works. By translating your business logic into Excel syntax, Claude allows you to analyze data like a seasoned professional, turning massive spreadsheets into actionable insights in seconds. This sequence diagram maps the perfect Excel workflow. The user starts by providing Claude with a clear layout of their columns and the desired outcome. Claude processes this and returns a complex nested formula, like an index/match, alongside a plain English explanation. The user then takes that formula and pastes it directly into their Excel spreadsheet. The spreadsheet instantly calculates and displays the target data. This loop eliminates all the frustrating trial and error usually associated with advanced spreadsheet functions. At some point, your code or your formula is going to break. It will throw a massive red error message. I need you to know this: every programmer, from beginners to experts, writes bugs. Debugging is not a failure, it is simply part of programming. When you encounter a cryptic error, do not panic. This is where Claude becomes your ultimate detective. Just copy the exact error message and paste it into Claude, asking, "What does this mean in plain English, and how do I fix it?" Claude will translate the machine jargon into an actionable fix. For tougher logical issues, use the rubber duck method. Explain your code line by line to Claude. Simply articulating your goal aloud to the AI often makes the logical flaw obvious. By systematically translating errors and explaining your logic, you build massive confidence and resilience. Look at the debugging loop. When your code fails and throws an error at the top, you do not give up. You copy the error message and paste it directly to Claude. Claude then translates that cryptic error into plain English and offers a suggested fix. You review the fix, understand why it failed, and apply and test the code. If it fails again, you simply loop back, paste the new error, and iterate. If it succeeds, you break out of the loop and move on to your next task. Embracing this loop is how you learn. Let's tie everything together with a real-time, highly practical use case: building a personal expense tracker in Python. Imagine you want a custom tool to log your daily spending, categorize it, and generate a quick report. The challenge is that this requires managing lists, handling basic dates, and performing math. Instead of writing it from scratch, you prompt Claude, "Help me build a simple expense tracker that categorizes spending." Break it into steps and explain the data organization concepts. Claude will output a structured Python script that prompts you for input, categorizes your purchase, and prints a summary. You can copy the script, paste it into a free, safe educational environment like Replit, and run it instantly. You have just gone from an idea to a working piece of customized software in 5 minutes. This proves that you can solve real-world personal and business problems without writing a single line of code manually. Here is the simple architecture of our expense tracker use case. The flow starts with user input, such as logging a $15 lunch. This data enters the Python script engine that Claude wrote for us. The script routes the data into a data dictionary, tagging it under the food category. Next, it passes through the calculation logic to update your daily totals. Finally, it pushes to the right, generating a clean summary output report for your review. It's a complete, miniature software application built in minutes through the power of plain English prompting. As we conclude, I want to leave you with the absolute best practices for building good habits early. First, demand good code organization from Claude. Ask it to use clear, descriptive variable names and to add heavy comments explaining the logic. Second, develop a security mindset. Never put real passwords or highly sensitive business data into your learning scripts. And finally, remember that your code does not have to be perfect on the first try. It just has to work. Programming is an iterative process of continuous improvement. By using Claude as your translator and mentor, you have unlocked the ability to build tools, automate tasks, and create software without needing a computer science degree. The barriers are gone. I highly invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Let's get coding! This final flowchart outlines your new continuous development loop. You start with a small idea and draft the logic in plain English. Claude translates that to code. You then test it in a safe environment and ask the crucial question, does it work? If no, you loop back up to debug with Claude. If yes, you break out to deploy and automate your task. This cycle of testing and debugging is how true mastery is built. Follow this path and be sure to check out quicktechie.com as your final step for continued learning.